Objects on an incline have the following components. F3 is the force of the surface on the object. F1 is the force of the object on the surface. F4 is the force that tends to make the object slide off the surface. F2 is friction, and F5 is weight. If we then do calculations, we would get F4 as weight sine theta and F1 as weight cos theta. Like in the previous video, you can calculate displacement of wind blowing on a plane or even rough seas on a ship. One can then apply Pythagoras, your sinus or cosinus rules, or like in the following example. We take, for example, a swimmer going at 1.5 meters per second over a 60-meter broad river. We calculate the time that it would take as 40 seconds by taking the change in distance on velocity. If the current moves left at 0.9 meters per second, we can get the displacement distance as 36 meters by taking velocity times change in time, which is 0.9 meters per second times 40 seconds. Newton says that a velocity of 1 meters per second causes a weight of 1 kilograms, which would lead you to the formula the resulting force equal to mass times acceleration. This is then also a vector amount. Forces on an object are in equilibrium if the object moves at a constant velocity or stands still. Newton's first law, or the law of inertia, says that an object is in equilibrium or moves at a constant velocity except if a resulting force works in on it. Inertia is the characteristic of an object to resist movement. It is measured in the mass of the object. Newton's second law of movement says that an object experiencing an unbalanced force will accelerate in the direction of the force. This law states certain equivalents. Acceleration is directly equivalent to force, conversely equivalent to mass, and directly equivalent to 1 on mass. Newton's third law of movement says that if one object exerts a force on another, the other exerts an equally large force in the opposite direction. An example of Newton's third law of movement is tensional forces. We have the forces of A on B and B on A, which is equal to each other. If this system accelerates upwards, the force of A on B is equal to the force of B plus MA. The tensional force of B is equal to the weight plus the force upwards. To do applications on Newton's laws of movement, you can use the following equations. V is equal to U plus AT, V square is equal to U square plus 2AS, S is equal to UT plus a half AT square, and S is equal to U plus V times T divided by 2. Newton's gravitational force says that all particles in the universe exert a gravitational pull on each other. The force is directly equivalent to the product of their masses and inversely equivalent to the square of the distance between their midpoints. The gravitational formula therefore says that the resulting force is equal to the gravitation constant, which is 6,7 times 10 to the power minus 11, multiplied by the two masses multiplied divided by the square of the distance between their midpoints.